I'll show you this contraption I've made, which is a dot matrix sort of clock, calendar, memo board based around these 8x8 LED modules. I think these are the 2-inch ones. There's my hand for scale. If I get it plugged in, I decided to use a Wemos D1 to drive it, mainly because I've got one lying around, but also it's got both micro USB and a barrel jack power input, which is nice. So I've got a USB power bank thing here and a micro USB lead. I'll power it up. Sorry, the camera work. So you can see it's connected to the Wi-Fi, and it's saying it's on 192.168.1.8. And what it's doing now, it's been to the internet and got the time from a one of those internet time server things, and it's displaying that at the top. It automatically, well, you specify in the code what time zone you're in, and then it automatically does daylight saving time correction. So here we're in the UK, and so it's saying it's BST, that stands for British Summer Time, and in the winter here we'll swap onto GMT, which is Greenwich Mean Time. Now the bottom two rows of the display, you can use them for anything, so that's partly why I left the Wemos exposed. You could like plug in, I don't know, temperature humidity sensor or something, but at the moment I've made it do a little web interface. So if I get my phone and I'll just and go to a web browser, and I've got to go to that 192.168.1.8 address. I don't know if you can see this, but that's all we've got. We've got 2 rows of text, and at the moment I'll put in a memo to say I'm going flying Saturday, well today actually, at 2:15. And then we can put anything you want on the rows. So if we put in a memo in there and put, I don't know, mum's birthday on Wednesday. So you put anything you want, shopping list, time to watch television or whatever. I also got a brightness. You can see you've got a choice of brightnesses, 0, 1, 2, 3, 4, 8, 15. It's on 2 at the moment. I'll leave it on 2 for now. And when I do update, you'll see it change. Now because that text that I entered for the 3rd line is too long to fit on the row, it's scrolling. So what it does is it scrolls if necessary and centers it up if it'll fit without scrolling. So if we change the that fly Saturday thing to, I don't know, you know, sort of buy eggs, milk, bread, whoops, and I'll also change the brightness this time. We'll alter it up to brightness 8, and when I do update, there we go. So you can see it's got brighter and change the message. Now the other thing you can do is it's got a sleep function on it. So if I touch the sleep button, I'll zoom out a bit so you can see it. As soon as I touch the sleep, look, it goes off. And then you've got a wake as well to wake it up again. There we go. I'll just tone the brightness down a bit. Normally for indoor use you can leave it on brightness 0. And there we go, you'll see it update now to brightness 0. And on this camera the reds look a lot redder when it's on 0. So as I say, it's based on these modules, these Max 7219 are they? Something like that. And you can get them in both 4-way and sort of 4x1 and 4x2 blocks. You can see I've got a mixture actually here. And all you do is the wires coming out of the Wemos are soldered onto the back of the board rather than having them plug in the front, and that leaves the wires in the front, the sockets at the front free for plugging in other devices. And then the signal and the power goes up these wires to the first module, which is a 4x2, and then it sort of goes through all those, and then that's daisy chained up to there, and then we've got a 4x1, a 4x1, a 4x1, 4x1, and another 4x2. And the only reason I got a mixture of 4x1s and 4x2s, I bought both to experiment with, but they will both fit actually. The 4x2 is just 2 of these 4x1s joined together and with the built-in daisy chaining wire. You'll know, I don't know if you can see actually, but they are slightly different colours. I've put the lighter coloured backgrounds on the bottom because the 4x2s came with different darker modules than the 4x1s. The 4x1s are about, I think they're about $3 each, $2 or $3 each on AliExpress. So you could get 8 of them for what, you know, less than $30 delivered. Also the Wemos D1, although it's sort of obsolete really, you can get those for $2 or $3, so it's a good thing to buy if you just want to do this. But obviously you could use ESP32 or anything. In fact, the driver I've written it'll work on any Arduino. It's Arduino IDE I used to do it, and it'll work on a Nano or whatever. But of course you want the internet connectivity to get the time and date and allow the web page update. Although of course you could always put a real-time clock if you wanted to do it on an Arduino. And the way I've done the driver for these things is you can sort of specify windows. I've specified 4 windows, which equate to the 4 rows at the moment, but you could do more than that if you wanted to. So you could split a row up into 2. The rows can straddle the sort of physical rows of the displays. They're pixel based, so you might have a block sort of here and another one here. It doesn't have to be per row. Anyway, that's it. Oh, the sort of frame I've made, it's all 3D printed in several parts actually, so as to fit on the 3D printer. But you can see it's got some hooks. The idea is I'm going to hook this on the wall using those keyhole slots, and then run it off either like a Raspberry Pi power supply or something with a barrel jack. When everything's lit up bright, it takes about an amp, which the Wemos power supply can cope with. So that's another reason for using a Wemos. If you used an ESP32 or something, with most of them, you'd have to put in a separate power supply. This is all running off 3.3 volts. I think I think the spec for these chips says they won't work off 3.3 volts, but they actually work down to 2 volts, no problem. Something to be aware of. You'll see, although you can daisy chain all the wires, including the power, I found that you can get sort of a significant volt drop by the time the power's gone through all the modules to get to the last one. So on brighter settings you end up with one side of the display dimmer than the other. And so I've connected the power lines using these red and black wires here, so it's more like a bus bar than a daisy chain. And in fact I've also connected the clock and chip select lines using these yellow and green wires, but that's not because of any volt drop, that's just to keep the wiring simpler. And the only one that you actually need to daisy chain are these white wires, which takes the data out to data in. I think these modules, if you were using just a 4x1 on its own or a 4x2 on its own, you'd probably put them the other way around. You say, I've got them stacked the wrong way. You know, they're meant to be like that. But for reasons best known to themselves, the manufacturers have left... sorry, I accidentally pressed the stop recording button. The manufacturers left gaps here. So if you do scroll the text across that way, it's a bit jerky. So if you're gonna scroll text and do it sort of, well, in 8 pixel high blocks ideally, then it's better that way, because there are no gaps between the modules going that way. I think that's poor layout actually by the manufacturers, but anyway, perhaps they had a good reason for it. This is a display module. It uses these 8x8 LED display blocks, and they're driven by Max7219 or similar chips. And you can buy these in a sort of 4x1 array, or this is a 4x2 array. And the connections on the back, you've got power, VCC and ground, clock, a sort of data in and versus data out, because they work like a shift register, and a chip select line. And so the idea is you shift the data into them and it shifts along through each chip in turn and eventually comes out of the connector at the other end, and you can daisy chain any number of these blocks together within reason. Now, for reasons best known to themselves, the manufacturers of this boards, whether it's the 4x1 or this 4x2, have spaced the blocks slightly apart. You can see there's a gap there between one block and the next, running on what you would think is horizontally, but that's bad news. If you want to scroll text across horizontally, it has to scroll past the gap and it looks a bit jerky. Whereas the other way, whether you've got the 4x1s or 4x2s, the chips butt up against each other, and then the spacing between the individual dots can remain consistent across any number of blocks. So it's actually better, if you're going to use an array like this, and you want it to be at least 32 pixels high altogether, it's better to put the blocks in like that, with the boards arranged vertically. So that's what I've done. Incidentally, this is a cut-off cocktail stick, and it's useful once you've got a number of these blocks assembled together and you want to remove one of the display LED things. because they're just pushed into chip sockets. This little cocktail stick, you can prod through the holes and get them out without bending the pins, whereas just levering them from the one edge, you tend to bend the pins getting them out. Okay, enough of that, and I'll move on to showing you how I connected them up in a frame to make the whole display. So here we are in Fusion 360, and I've designed this spreader bar that allows us to bolt well, 4 of the 4x2 modules to it, or you could use 8 of the 4x1s, or I've actually got a mixture of 4x2s and 4x1s, it doesn't really matter. Now that spreader bar is actually too big to fit my 3D printer straight across. Here we are in Slicer, but you can see if you put it on the diagonal, you can print them, and you can print 2 or 3 at a time. And you can see I've incorporated a sort of keyhole hook there so that we can hang the thing on the wall. So with a couple of those bars printed out, here's the modules screwed to them, and I've actually got, this is a 4x2 at this end and a 4x2 at this end, and these are actually 4x1s. So that's just what I happen to buy. If I was doing it again, I would buy all 4x2s because it keeps the interconnections simpler. So we've got the if you're making one of these, you notice that this is the input end of things with the arrows pointing down, so the modules are running that way, and the first input cable from the microcontroller goes in to what will be the top right hand corner. But bear in mind these are shift registers, so in terms of the data that you clock out, it will go through these 4, then these 4, and so on, and eventually end up at this bottom left hand corner. So that's actually address 0. It's a bit confusing. That's address 0, address 1, 2, and so on, but the connection goes in on address 31 in terms of chip numbers. Now if we look at the back, there's the cable coming in from the microcontroller, and I fitted more of these connectors than I really needed to, because this is when I was experimenting on the bench. But that's the first input to a 4x2. That's the output end if it was a 4x1, but because it's a 4x2, that's internally linked down to this one. You don't have to jump at that, and then that's the output of that one, and so on. Now you can daisy chain all 5 wires through the modules, but I found that the 2 power lines, you get a significant volt drop across all of them if you're driving the LEDs at their full brightness, because the power's having to run through every board along the tracks. So it's actually better. You can see on here I've jumpered the VCC and the ground wires together with some red and black wires, and in fact the chip select line and the clock line are common to all the modules as well, so there's no need to daisy chain those either. So I've done those with the yellow and green wires, although they're taking a lot less current, but it makes the wiring neater if you do them like that. So there's the first actual daisy chain wires coming from the output of that 4x2 module to the input of the 4x1, and then I've got to also add wires from there to there and so on, diagonally all the way across until we get to the last 4x2 input. Other things to note, you'll see I've fitted a resistor here on each module between VCC and chip select. Quite a high resistor. I think it's a 820k or 82k, something like that. And the idea of that is it stops the sorry, it's 68k, I think. Is that right? Yeah. It stops the chips clocking rubbish into them during the power up stage, which, if the chips happen to go full brightness or self-test mode with all LEDs illuminated, it can draw too much current and overwhelm the power supply. So the idea of the resistors is it keeps the chip select line pulled up high, which is not selected until the microcontroller actually really wants to send data. So you can see I've put them on the spreader bars. There's only 2 screws needed there for the 4x2 module, and then the ones in the middle are all 4x1s. They've got 2 screws on each module, another 4x2 that end, same on the bottom spreader bar. And if you're making one of these and you're doing it in the orientation that I've done it in, the little marker sort of nipple on each of the 8x8 LED blocks ends up on the right. That's in the centre of the chip. You see there's a little point there in the centre, and there isn't one that side. And there's also usually some there's some sort of marker date writing or something usually on the end with the little ID. So that's the first stage. Get them screwed to the 2 spreader bars and wired up. And the next stage I'll show you how I design and fit a sort of picture frame around the edge. Here's the frame for the thing, done in Fusion 360. You can see there's the box for the Wemos, and then there's the spreader bar with a little keyhole hook for hanging it on the wall. You need 2 of those, and then the frame's done in 4 pieces. There's the bottom, left and right hand sides, which are the same, and the top. The only difference between the top and the bottom is the slots to let the Wemos case dock and let the wires out. The pieces are actually too long to fit on a Prusa printer, which has got about a 250mm square roughly print area, but if you put them on the diagonal you can see they'll fit. So you could print them all out at once, although I actually did them a bit at a time. And if I slice those now, there you are. So there you can see how you could print out a complete set of parts.